a Klipsch bookshelf speaker. This is the baby of the range. This is the R-14M. I believe it was released in 2014. I got this one in 2016. I'll throw up the spec sheet right now. It has a 4-inch woofer, 1-inch tweeter, and on a desk, I think this is the best speaker I've heard, which is surprising to a lot of people because this is a cheap budget speaker. But there's a magic to this thing that I haven't heard in even speakers that were triple the price and 6.5-inch woofers. There's something about these little woofers that really bring life out of the mid to high bass, and this tweeter, although probably very cheap, I think does a really good job at bringing out the bright highs. So let's take it apart and see what makes this thing tick. I should mention now that this is not stock anymore. I have made a couple modifications to quiet down the enclosure and to just kind of tighten everything up overall. So you can still get these things used online. I'll throw up a Amazon page. They're, I think, $150 used. Who knows what true condition they're going to be in, because used means a lot of different things. So buyer beware, as usual. Taking these things apart can be a little tricky sometimes just because the connectors don't like to come off of the terminals on the drivers. A little bit of persuasion takes care of that, though. If you've never seen inside a speaker before, you might be surprised at how little there actually is going on in one of these things. And that's for a couple of reasons. One, you don't really need that much inside of a speaker. And two, things cost money, and companies don't like putting unnecessary stuff in a speaker. The only things you're going to find in here are what is absolutely needed to get the best sound per dollar out of it. And that helps you and it helps them. If this thing was built to the highest standards possible, it would not be something most people could afford. I would estimate that Klipsch got this thing out of the factory for about $40. Could be a little more, could be a little less, but I think 40 is a reasonable cost, because if you think about it, they have wages to pay for, they have lighting and other things to pay for, they have their marketing team to pay for, and all of that overhead has to be paid for somehow, and it's paid for by you, the consumer. So here is the mostly stripped enclosure. You can see the port tube in there, and then you can see this stuffing. This stuffing, if you buy it from acoustic suppliers, will cost about $1,000 per square inch. That's a little bit of an exaggeration, but all this stuff is polyester blanket stuffing. So if you want to buy some or add some to your enclosure, if it doesn't come with it, just go to any fabric store and you can find blanket stuffing, shove some in there. You can see that there is some foam inside stuck to the walls here. This is adhesive 3-layer foam. This is to not only add mass, but to dampen out this 5/8 inch thick MDF enclosure. If I give this a knock, you can hear that is actually pretty dead. it used to ring quite a bit more than it does now, and adding all this foam in here has really helped. So that's the first modification that I made. The second modification I made is to put a fillet around the inside and outside of the woofer cutout, and this helps to minimize diffraction inside of the box. Are you really going to hear that? Probably not, unless you have really good ears or you know what to listen for. And that's really all there is to the enclosure. You can see the sticker on the back here, rated for 50 watts at 8 ohms. These things are pretty loud on a desk, but don't be fooled. These will not fill a whole room or a larger room. So let's take a look at the woofer. You can see this has also had a small modification by me. This is some blue tack. This will not last forever. It will eventually get hard and have to be removed and replaced. This is to dampen any ringing in the steel frame. See if you can hear it. You can still hear a little bit of that ring, but it dies away pretty quickly. So the combination of this sticky tack here to dampen out anything in the frame and it being bolted rigidly inside of that enclosure helps to pretty much eliminate any ringing. It does not have, this is not vented, the spider is not vented, and it is a plastic, a poly woofer. I've been very impressed with these, even considering that on paper they may not spec out to be the best. The tweeter got the same treatment of having some blue sticky tack put into all of the areas in here that would ring. Not a lot, but it helps to quiet down the overall sound of the box. Any one of these modifications you probably wouldn't hear, but if you put them all in place, it does become somewhat noticeable. So here is the very cheap crossover. We have a sandcast resistor, an iron core inductor, and some electrolytic capacitors. The things on here that you do not want to see on a top grade crossover is everything you see here. You don't really want your signal running through this circuit board material. Sandcast resistors dirty up the sound. Iron core inductors will, if they are saturated, maintain magnetism and muddy the sound in the bass. It's more apparent in higher frequencies, which is why they actually do spare the cost for an air core inductor on the tweeter circuit, because that is noticeable to most people. And electrolytic capacitors, these aren't really what you want to see because they aren't designed to have the sort of signal going through them that is being asked of them. But most people probably wouldn't know the difference, like non-audiophiles wouldn't really know the difference between these and the poly capacitors. So we have over here, this capacitor and this inductor are for the woofer. The woofer positive is red, both negatives are black, and the tweeter positive is this greenish teal. The tweeter has a resistor in series, a capacitor in series, and then this air core inductor is in parallel. The woofer, this is in series, and the capacitor is in parallel. So I'll draw out that schematic for you and give you the values. Whoop. Minus. So over here, I will put the tweeter. The signal will come in, go through that resistor, which is 6.2 ohms. It will go through the capacitor, which is 3.9 microfarads. And then it will go back to negative, and in parallel is a 0.27 millihenry inductor. And that's all that there is to the tweeter circuit. On the woofer circuit, there is that 1.0 millihenry inductor, and then a 25 microfarad capacitor in parallel. So if you want to upgrade this crossover, go on to any reputable source. Parts Express is the go-to. There are a couple other ones. One that I've used for resistors specifically, I will link to in the description. I have no affiliation with any companies, and I'd like to really keep it that way. And then all you have to do is point-to-point solder all those components together. There's debate, just like everything in the audiophile community, everything is up to debate. Some people say that these sort of 5-way binding post terminals are really bad because they have ferrous metals on them. I don't disagree with that, but due to availability of alternatives, I just say go with these. They aren't bad enough to where you need to spend tons of money to upgrade them, unless you're really looking to get that, last little bit. So I'll also throw up some higher quality images of the circuit board so you can see how this is laid out on the board. But if you're going to replace these, this is what you need. This doesn't really help you. You can see this one is actually from 2015. So when I bought mine in 2016, this was already a little bit old. I think that's all there is to it. As I said, this is one of my favorite little speakers. I always keep that. I've had this pair on my desk and kind of moved them around my my audio setup for a long time. I recommend picking up a pair if you don't mind risking getting it used. Definitely put some foam on the inside, because that costs you a little money. Chamfering this is free. Adding tack to the woofers costs a couple bucks. It takes more time than money. And really that's all there is to it. I did price out what it would be to get upgraded components. And for the total price for the pair to upgrade them would be at most $80 if you went with the highest quality components, but you could get it down to as low as $40 if you stuck to the cheaper components. But if you're going to upgrade to higher quality components from cheaper components, why would you bother going with the cheaper end? Go with the higher end stuff. As I said, I'll link a couple websites down in the description where you can find some of these components. If you can't find the exact values, for example, if you can't find a 25 microfarad capacitor, you can put 2 capacitors in parallel. So you'd put another capacitor here, and each of these would add up to 25. So you could have a 13 microfarad and a 12, or a 15 and a 10, and that would give you the same capacitance. It might not work, it won't work exactly the same as one capacitor, because that's the way physics works, but it'll be close enough that you probably won't be able to hear a difference. And if you can't get a resistor, you can either put half values, or I should say additive values in series, or deductive values in parallel. There's calculators for that online as well. I recommend upgrading these. I haven't upgraded my crossover yet, but I will in the future. I've upgraded the crossover on another pair of speakers I have, and going from those cheap components to proper poly capacitors, air core inductors all the way around with the thicker gauge wire and higher quality resistors, it really opens up the sound to something that you would really want to listen to more than the stock version. So I can't recommend this enough. Upgrade these if you can. Even if you have a different speaker, if you don't have an R-14M, you can apply these same principles to those speakers. Just remember the values on the crossover will be a little bit different. If anyone actually tries this, let me know and tell me what your results are.